What's up guys, my name is Faisal Al-Edaily and welcome back to another episode of Celestia. Today we're going to be checking out some random Kepler and HR systems, star systems. So we're going to be checking them and exploring them basically. So first we have Kepler 1. So we press enter, we can just go to this searching box. So we go to target name, type Kepler-1 and then we're here. So let's zoom out a bit because it is when you type it, it goes to the middle of the solar system itself, not the stars. So we have Kepler 1a and Kepler 1b. So let's see A first. When the star is named A in these exostars, these stars, they're mostly the bigger one. So this one's basically the same size and mass as the sun, and same temperature too. The luminosity is just a bit bigger than the sun. It's actually very similar to the sun. Even the rotation period is 25 days, which is also exactly like the sun. Wow, okay. It's very similar to the sun. Okay. Here it is. And it has a planet orbiting around it, which is actually a pretty big planet compared to it. And it's spinning super close to it, as you can see. It's called this Kepler 1ab or TRES-2 AB, has multiple names. So here it is. Whoa, these cloud formations or whatever these are really, really cool. I'm not sure what these are, like storms maybe? I'm not really sure. They could be storms. Whoa, what are these? Like lava? The temperature is almost 1200 degrees. I can see why. It's like lava. Wow, this is super cool. That is really cool looking. It's actually pretty big. It's bigger than Jupiter. It's 1.253 the mass of Jupiter. By the way, MJ means mass of Jupiter. And that's it basically for Kepler 1a. There's another star though, so we're not done with that one. So we have this. Here's Kepler 1b. Let's go to it. And this is another red dwarf, it seems like, and also has sunspots. This part, the dark spot, the dark middle of the sunspot is called the umbra, and the lighter parts around the edges is called the penumbra. The umbra is 1500 degrees cooler than the whole star, Celsius. So the star itself is 3400 degrees Celsius. The umbra would be approximately 1900 degrees Celsius. That would be the temperature of the umbra, which is the middle place of these sunspots. And also it has a class of M5, and it's much smaller than the sun in radius and luminosity, I guess. It's 0.0000163 times the sun, and it doesn't have any planets around it. It's just a red dwarf orbiting another yellow dwarf, which has a planet, gas giant, which is very close to it. That's like the recap for this. So next we have Kepler 2. So we had Kepler 1, now we have Kepler 2. So let's type that. So we're going to Kepler 2 right now. By the way, press G. If you press G, you can go to the place, by the way, if you didn't know. So let's zoom out a bit more. There we go. Kind of gotta zoom out a lot to see like the actual stars, but that's okay. So we have this one. It is bigger than the sun. The rotation period and surface temperature are basically the same thing. And also it has 6 times the luminosity of the sun. And if it has 6 times the luminosity of the sun and there's a planet that close, that's probably like the hottest planet ever. 1670 degrees Celsius. Honestly, I feel like it should be more, but that's okay. And this is also a very big gas giant with cool cloud and hurricane formations. Wow, I love this. 1.7 times the mass of Jupiter. Dude, this also has like weird lava hurricanes. Maybe they're not lava, I'm not really sure. But it looks super cool. I love that. So there it is. These are really cool. And there's also Kepler 2b. I'm just gonna search it from here. Here it is. It's another red dwarf. A little bigger than the last one. Has a surface temperature of 3000. and even like luminosity, like specific luminosity for red dwarfs sometimes. So some red dwarfs may have the same luminosity, or maybe even brown dwarfs or other stuff like that. But now we have Kepler 13. Or actually, let me search Kepler 13a just so we don't waste our time. So let's go there. Here it is. So it's a pretty hot star, so that's why it's like in the white to blue range. And it's also a bit bigger than the sun. Luminosity is about the same as Sirius A. The whole star itself is actually really similar to Sirius A. Wow, it's like that's really cool. And this planet is also orbiting super close to it. How come all the planets are orbiting super close to it? And this one's 6.5 times bigger than Jupiter. This could even be classified as brown dwarf, maybe. Here it is. And it also has these weird lava formations. And this one's even hotter. It's 2,200 degrees Celsius. Wow, lots of the planets we're encountering are very huge and very close to the stars and like all lava. I love that, actually. I just can't get over how cool this looks. Wow, okay. Next we have Kepler 13b, I think. Yeah. And it has a lot more planets too. Oh, wait. So it's like, so Kepler 13b. So we have BA and BB. We'll check out BB first. Let's see what this is. So it's much smaller. Is this like a white dwarf? No, it's a red dwarf. It's a red dwarf orbiting around a white dwarf. I guess they're still in a binary relationship, so the red dwarf does have like a similar thing. So this is a trinary star system right here. It can affect the gravity of the white racing star. The red dwarf can affect this star's gravity. This one's also like a very similar star to Sirius A, a little smaller and cooler and less luminous than the last one, but it's actually pretty similar. So that's really cool. Next is Kepler 20. So let's go to Kepler 20a. Here it is. Wow, there's a lot of planets in here. This is gonna be fun. So we have Kepler 20, here it is. The luminosity is less than the sun, a little cooler than the sun, about the same size. So it's a less luminous star than the sun. So this is gonna be interesting. So we have this planet, first of all, Kepler 20ab. It's very hot and very close to the star. It's like around 900 degrees Celsius. It's finally a rocky planet. So this is actually a pretty big rocky planet. It's 9.7 times the mass of Earth. And E means mass of Earth. So here it is. It's a pretty big rocky planet. Surprised it's not a gas giant. Then we have Kepler 20. Wait, no, not this one. Or no, it is this one, yeah. Okay, never mind, it is. Kepler 20 AE. I thought it was the one of the last planets because I thought it's gonna be AC, but no, that's not how it works, I guess. So here it is, Kepler 20 AE. It's also a pretty hot star. It's pretty close to Earth, or the sun. 729 degrees Celsius. Where is its mass? It doesn't say its mass for some reason, but that's weird. Maybe if no, that's really weird. It's a little smaller than Earth, I know that. So that's cool. Next we have 5 planets here, yeah. That's actually a lot of planets. There could be even more, actually. Wait, that's not the planet, that's a star. Okay, there we go. And lots of these stars, they may have planets that we still haven't discovered because they're so small. Okay, this is a gas giant, I think. This is really cool looking, wow. So it's 498 degrees Celsius. That's about the temperature of Venus. It's 11 times the mass of Earth. That's like a little smaller than Uranus. And in radius, it's a lot smaller than Uranus. Well, it's like a bit smaller than Uranus. Or Uranus, I guess. Let's just say it like that. Next, we have Kepler 20 AF. Here's Kepler 20 AF. The TRAPPIST-1 system does have a lot of planets too, just like this. They all seem like they have the same look, like they look the same. Or actually, that one planet that had clouds and stuff, that's different actually. The one that we just saw. So this is a rocky planet, 400 degrees Celsius, about the same radius as Earth. Kepler 20 AD, I think, is the last one we haven't seen. Here it is. So it's another cloudy one. This one is about the size of Uranus, basically the same size, a little smaller or massive as Uranus, and it's like 60% the radius, so it's denser than that, denser than Neptune probably even. And this is the only actually like kind of not like planets that you can burn on, because this one's only 97, which is still like that's like close to the burning or the boiling water limits, the boiling point of water. Anyways, next is Kepler 130. So let's go there. Go to Kepler 130a first. So here it is. It's about the double the luminosity of the sun. A bit bigger, just a bit. A little smaller, or a little cooler, I mean. A little cooler. And we have 3 planets orbiting around it. Wow, we're seeing a lot of planets here. And I like that. Okay, here it is. It's a very hot planet. Another rocky planet. About the same radius as Earth. Actually, it's very similar to Earth. Here it is. And this is one of the 3 planets. But it's not supposed, I feel like it's supposed to be Kepler 130 AB, not AC, since it's the closest one to the star, but you know, who cares? Next we have Kepler 130 AB, and then I think it's, okay, next is D. So this one is, it's a pretty big star, or planet. It's another cloudy one, pretty hot, about the temperature of Venus. Around 60% the size of Uranus or Neptune, I guess, or anything. They're basically the same size. Uranus and Neptune, they're basically the same size. Okay, Kepler 130, and then AC, or Kepler 130 AD. AD is after this, yeah. And also, I just realized we didn't see the other star of Kepler 20, so we'll come back to that. So here it is. It's 200 degrees Celsius, still very hot. Radius is a bit bigger than Earth, and that's it. Rotation period is 87 days. That's a lot. Still nowhere near as much as Venus, because Venus is like what? It's like 245 days. Also, fun fact: Venus's rotational period is longer than its orbital period. So a day on Venus is longer than a year, because a day is 245 Earth days, and then a year is 225 Earth days. That's the fun fact. So let's go to Kepler 20b. Let's go back to the last system, because we didn't see this star. So it's another red dwarf. It's 0.000649 luminosity. This one doesn't have that one script thing where it's 163, but that's okay. Surface temperature is 3000, quarter of the radius of the sun. Rotation period 4 days, class M4. That's it. Let's fly to it, because why not? So you can see if you hold A, you can become faster. At the bottom left, it says speed. We're at 0.658 the speed of light. Okay, we just went inside it. We're probably dead now, because we melted. Where is it? Hello? Oh, no! Okay, we're going inside it. That's great. If you press S, you can just go to 0, so then you don't move anymore. Where's the planet again? Here it is. Now that's Kepler 20a. You can see like a view of the other star from this star. That's really cool. Okay, that was chaotic. Next is Kepler 132b. Luminosity is very, very similar to the sun, and radius is 1.1, so it's pretty similar to the sun in radius and luminosity. and surface temperature is also very similar. So this is a very sun-like star, and its rotation period is also 25 days. So it's very similar. I like that. And the other one, Kepler 132a, it's a bit more luminous. Basically the same temperature of the sun, the same radius. Wow, these are very similar. Interesting. Okay, so it has, wait, are these, okay, it has 4 planets. That's a lot. These are 2 planets that are like very, very close to each other. I've never seen something like that. I guess let's do the closer one first. If we go land on the sun, let's land on the sun. So I'm holding A right now, by the way. Or not the sun, I guess Kepler blah blah blah. Okay, so we're now on the surface of the sun. So now let's go to Kepler 132 and then AD. So that's 9.67 million kilometers away. Now 132 AC, that is, so only like 50 million or 50,000 kilometers. Those are super close. Like that is, they might even collide with each other or something. Cool. I like that. Okay, let's go back. Kepler 132 AC. Here it is, just a rocky planet. It's very hot. Here it is. And we also have Kepler 132 AD. Yeah, D was the one that's very close. They're pretty similar to each other. Similar temperature. I didn't really look at the radius of the other one, but I think they're pretty similar too. Next is Kepler 132 AB. Yeah. So this one's 498 degrees Celsius, about the surface temperature of Venus. Here it is. It's a lot bigger than Earth. It's like a super Earth, but it's a rocky planet. It doesn't have life, or anything like that. So it's not very Earth-like. And finally, we have Kepler 132 AD. No, AE. This one's 153 degrees Celsius. How come all of these planets are very hot? Like I can never see a planet that's actually kind of cold. Like if I go to the actual star, it's kind of hard to see. Distance is 95, wait. How's the distance 95 AU? That doesn't make sense. Okay, you know what? Who cares? Here it is. Okay, so we are now done with the Kepler. Now we are entering the HR. So we have HR6A first. Okay, we're going very far. Whee! What was that? So it's surface temperature hotter than the sun, a little bigger. Has a planet. Let's check it out. Hello? That was weird. Ooh, it's like a very Saturn color. It's also about the size of Saturn, or the mass of Saturn. It's a little smaller, a little less massive. We have HD 142/HR6, A, B, and C next. So we have this. It's a very big planet, bigger than Jupiter. It's very hot too. Wow, this is also very similar to, well, it's not that hot actually. It's like Death Valley temperatures. It's also very similar to Saturn. Why do all these look like Saturn? Like without the rings, of course. And then finally is HR6A. Wait, no, I can't like search it like that, the planets. AC. So here it is. Wow, this is a huge planet. This is the biggest one yet. It's 11 times the mass of Jupiter. Wow, this looks so similar to Jupiter. Why does it look so similar? Except it doesn't have the great red spot. That said, wow, this is a huge planet actually. Wow, okay. And it's very cold too. It's pretty far away from the star. Next we have HD 142, but B, the other star. It seems like it's a red dwarf. It's like between a red dwarf and a yellow dwarf. It's like an orange dwarf or something like that. Looks cool. Cool. Yeah, nice. Next is HR 1474A, I guess. Let's go for that one first. Here it is. It's a pretty hot star and pretty luminous. A lot more luminous than the sun. Has a planet. Let's see it. It's a pretty huge planet. It's 4 times the mass of Jupiter. Why does this also look pretty similar to Saturn? Wow. It's also pretty cold. It's negative 168 degrees Celsius. That's very cold, actually. Okay, cool. Next is not Kepler, HR 1474b, the other star. It also has planets. So both of them has planets. That's pretty rare. Wait, these are not planets. These are two. Oh, it's another trinary system, I guess. So there are 2 red dwarfs. Let's not look at them because why? Like it's kind of a waste of time. We know what they look like basically. Next is HR 166A. Has a surface temperature of exactly 5,000 degrees Celsius. That's really cool. Cool. It has a planet. It's like around the size of Saturn, or mass of Saturn, a little less. There it is. Looks very similar to Saturn too. Cool. Love it. Temperature is 58 degrees Celsius. Next is HR 166b. If it has planets, we're not looking at them. Ooh, is this a brown dwarf? Wow. I think this is actually a brown dwarf. Wow, okay, I really like this. Brown dwarfs and Celestia look very beautiful. Here it is. I really like this. Next we have HR 3323. This is the final solar system of the day. So here it is. It's called Mesida or something like that. It has this star A, and it's this. We're gonna look at the planets. It's a huge star actually. The luminosity is 111 times the sun and 14 times bigger than the sun. That's actually very big. That's the biggest star we've seen yet. Here's the planet, very Saturn-like. So they're just generating an image for it, what they think they look like, and they're all Saturn basically. But it's probably not even similar to Saturn because it's probably not even that realistic on these things. 3.65 times the mass of Jupiter, so pretty huge, and it's pretty hot too. And then we have HR 3323b. Here it is. It's a pretty small star. It's another red dwarf. Whoa. Yeah, it is a red dwarf. I guess you can say it is, but it is pretty big though. Okay, there we go. I love it. That's it for Mesida. That was the 10 star systems, Kepler and HR. So yeah, that's gonna be it for today's video. If you enjoyed it, feel free to hit that like button and subscribe if you haven't already. Turn the button gray, and I'll see you guys in the next video. Peace out.